This video's topic is radical equations, and it comes with one simple note and some examples. The one note is isolate the radical. All right, if you do this, you're going to be on the right track. All we're doing here is we are solving equations, so we want to end up with the x or whatever the unknown letter is. We want to end up with that equals a number. And we do that by undoing all of the steps that have been done to x. So when you first learn to solve equations, x minus 4 equals 7. The reason that we did plus 4 here and plus 4 here is because the opposite or the inverse operation of subtracting 4 is adding 4, and you got x equals 11. The inverse operation of a square root is a squaring. So if we get the radical by itself and then we square both sides, then we're going to be in good shape. So let's start with just the most simple of examples. If the square root of x is 3, the opposite of that is squaring, so x equals 9. All right, no brain buster there. 9 is the value that makes this statement a true statement. That one, the radical was already isolated. There was nothing to do. This next example, the radical needs to be isolated. So when I isolate it, that's going to involve subtracting 1 on both sides, giving me the square root of x minus 2 equals 4. Now I square both sides and get x minus 2 equals 16. And since there was an operation under the radical, then I have to go and undo that, and I get x equals 18. All right, 18, if you sub that back in, right here for x, you get 18 minus 2 is 16, the square root of that is 4, 4 plus 1 is 5. It's important to plug your answer back in and check it, and we will discuss that more in a moment. But before that, I just want you to know that these operations, these steps apply to cube roots as well as square roots. This next example has a cube root in it. We still want to isolate it. Get the cube root of 3n plus 2 is equal to negative 1. Now I want to cube both sides. So 3n plus 2. And over on this side, negative 1 to the third is negative 1 times negative 1 times negative 1, which is negative 1. Subtract 2 from both sides. Get 3n equals negative 3, which implies that n equals negative 1. All right, if you check that quickly by subbing it in right here, I get negative 3 plus 2 is negative 1, cube root of that's negative 1, plus 1 is 0. So there's some nice basic ones, and our one note thus far is to isolate the radical, square both sides, slash cube both sides, and solve from there. Okay, so this next example, it's not really possible to isolate the radical because there are two radicals in it, but that doesn't make this thing any more difficult. It actually makes it a little bit easier. If you have square root equals square root, you can just go ahead and square both sides, and then those square roots might as well never have been there. If the square roots of these two things must be equal, then the two things underneath must be equal, and we get a nice equation with x on both sides. I'm going to subtract 4x from both sides, and I'm going to add 13 to both sides. 7x minus 4x is 3x. 5 plus 13 is 18. Divide by 3, and x equals 6. All right, so if I plug that back in, x equals 6, right here, I get the square root of 42 minus 13, and over here I get the square root of 24 plus 5. 42 minus 13 would be 29. 24 plus 5 would be 29. Got a true statement. 6 works. All right, so if you have a radical already on both sides, just go right to the squaring. There's nothing really to isolate. Okay, next one. Another one that we cannot isolate the radical, but this time I don't just have radical equals radical. You need to watch out on this one for some common errors. I want to go straight to squaring both sides. This side, x minus 3 when I square it. the right-hand side, when I square it, is x plus 4 plus 1, correct? Not correct. Good. When I square the right-hand side of this equation, I square the whole right-hand side of this equation, which means I am going to be multiplying out the square root of x plus 4 minus 1 times the square root of x plus 4 minus 1. You cannot just square a binomial. A binomial means two things that are either added or subtracted together. I cannot square that by just squaring both parts. I square that by writing it twice and doing the FOIL process. So that one times both parts, and that one times both parts. My x minus 3 on the left is fine. On the right, I'm going to get x plus 4. That's what I get when I multiply the two square roots together. Then I'm going to get minus the square root of x plus 4, and I'm going to get that again with the inner terms. I'm going to go ahead and combine those two next terms to make 2 square roots of x plus 4, negative, and then negative 1 times negative 1 is plus 1. Okay, now I'm in a situation that I'm more comfortable with. I just have one square root that I can isolate, and then I will square both sides and get my answer. This one's going to get even more simple because if I subtract x from both sides, those x's are gone. If I, let's see, on the right I have a total of plus 5, so I'm going to subtract 5 from both sides. I get negative 8 on the left, and I get negative 2 times the square root of x plus 4 on the right. Alright, I just did a minus 4 and a minus 1 in one step. I could have just combined them and then subtracted, but I think you're with me. My radical is not fully isolated, so I'm going to divide by negative 2, which gives me 4 equals the square root of x plus 4. If I square both sides, I get 16 equals x plus 4, and if I subtract 4 from both sides, I get 12 equals x. Okay, so quick check. If I plug in 12 on the left, I'm going to get the square root of 12 minus 3, which is the square root of 9, which is 3. On the right, I'm going to get the square root of 12 plus 4, which is the square root of 16, minus 1, which is 4 minus 1, which is 3. So it worked. So 12 is officially my answer. Okay, so I'm checking these to prove a point, and here is that point. Okay, so why do we need to check our answers? Here is a good example. Let me get rid of this part. Okay, so if I have an equation like the square root of x equals negative 5, I think if you just study that and observe, there's no x value that makes that true. You can't square root anything and get a negative number. However, if let's say this is part of a more complicated problem and you're just following your one note that says isolate the radical and square both sides. So what happens if you square both sides of this equation? I square both sides, and on the left I get x, and on the right I get negative 5 squared, which is 25. You have just done right there what's called an irreversible step, going from here to here. It's irreversible because if I take this new result and I square root both sides, which should be legal, I get the square root of x equals 5. But that's not what I started out with. I started out with the square root of x equals negative 5. The fact that both positive and negative numbers squared result in a positive is kind of the reason behind this irreversible step. So if you're solving an equation that involves squaring both sides, it's possible that you are creating solutions that are not really solutions. Okay, 25 is not a solution to this problem, although it kind of looks like it should be. So let's look at a more complicated example and show why you really need to check these answers. Alright, so let's solve this one. I can't isolate the radical. I can square both sides. Remember, squaring it is not just making it 25 plus x. On the left, I get x plus 15, because that's just one square root that's getting squared. Cancel the square root symbol. On the right, I need to FOIL out 5 plus the square root of x multiplied by itself. Okay, so that gives me 25 plus 5 times the square root of x plus 5 times the square root of x is plus 10 times the square root of x. And square root of x times itself is x. So when I solve this equation, again, the x's will cancel. And I can divide both sides by, I can subtract 25. And I get negative 10 equals 10 times the square root of x. Divide by 10, get negative 1 equals the square root of x. And at this point right here, you should stop and say no solution. All right, you can't square root anything and end up with a negative 1. I do not want to go on to squaring both sides and getting x equals 1. All right, that is not a solution, because if I sub negative 1 in, I do not get a true statement. All right, so negative 1 would be an example of an extraneous solution. After I square both sides, I get x equals 1, but that is not a true solution, because if I plug 1 back in to my original equation, on the left I get the square root of 16. All right, because I plugged the 1 in. And then on the right, I get 5 plus the square root of 1. All right, square root of 16 is 4. Square root of 1 is 1, so 5 plus that is 6. So since 4 equals 6 is not true, 1 is an extraneous solution. So my final answer is no solution. 1 is, sorry for cutting that off, extraneous. All right, so if you get a solution like that, list it, but make sure your overall answer is no solution and that you call it extraneous. You cannot say that 1 is a solution, and you want to be a little more specific than just saying no solution. All right, so watch out for those. Check your answers in the final result. You might see before you ever get to that final result that you're not going to have one, but you won't always. When I ended up with negative 1 equals the square root of x, I knew at that point I had a problem. Sometimes the problem won't be that obvious. So when you square both sides of an equation, check your answers, watch out for extraneous solutions, and you should be in good shape.